Today's topic is transistors. So what are the transistors is basically a transistor is device which will amplify weak signals. Amplify weak signals. So let us see how are the transistors formed and what are the types of transistors. So a transistor is formed by sandwiching one type of semiconductors between the other type. So let's suppose there are two type of transistors. First is NPN. The next is PNP. These are the two type of transistors which occurs. So how NPN is formed is that in this way. Here NPN. Here P is sandwiched between two N-type semiconductors. Similarly, in this case, what happens is PNP. In this case, what happens? N is sandwiches between two types of P-type semiconductor. So this is the formation of a. It has, by this you can say that it has three terminals. What up? First this terminal. First this terminal. First one this terminal. Again here there are three terminals. 1, 2, 3. So important things which we have to know about transistor is that first important points what we got. First it is of two types. What are those two types? NPN and PNP. Second thing, it has three terminals which are first on N side, second on P side, then again on N side. Or third we can say that, what can we third say? It has two PN junctions. Two PN junctions how? One this and one this. So by having a two PN junction, we can also tell that it has two diodes. We can say that it has two diodes. Why? Because diodes mean NPN junction or two PN junction, or you can say the two diodes. Now let us name these 1, 2, 3 terminals of a transistor. Now let us name what these terminals are. So naming terminals of transistors. What are these terminals suggest? First terminal is ammeter. What is ammeter is? It basically is a source of forward charge carriers. So it is always forward biased to ensure the flow of current. Second thing of having a forward bias and being a source, so it is a heavily doped. Why it is a heavily doped? Because we need a greater concentration of majority charges, which we will discuss later. So second thing which is there is collector, which is this terminal, this one, third one, collector. So collector is reversed biased because it collects the majority charge carriers, as the name suggests. And to stop the flow of current, it is reversed biased, and it is weakly doped because it does not require to have a greater concentration, so it is weakly doped. The third thing is base. This middle section is known as base. This middle section. So now this middle section is thin and it is moderately doped because it have to transmit the majority charge carriers from collector to from emitter to collector. Let me give you, first of all I will highlight this. What does it suggest? This is the ammeter and what is the terminal suggest. So let me give you a quick review, or you can say that, yeah, how it what I want to say. So suppose this is a transistor. This is a transistor. What we will do is, suppose it's a NPN. So this will be a forward bias, that is this will be a forward biased and this will be a negative biased. So what happens, this is an emitter, so electrons from here travels to here, it combines with few holes present here and the certain travels to here. Here the holes are getting from the battery, so it will get diffused to it, and these holes prevent the interatomic repulsion between the electrons present here and which are coming. Also this also gives a hole to it to prevent the more for exciting a more electron hole combination. NPN. So here we know ammeter is always forward bias, so it is have such a circuit. We know it is a negative bias, or you can say reversed bias, so it will also have this kind of circuit and it will connect it to a base. This is please remember that this is emitter, this is base, this is collector. So here first of all, which we think this is important to that I want to tell you, that we take the direction of conventional current. Conventional current. Conventional current. So what is the direction of a conventional current is? That is positive holes. Positive holes direction, which is opposite to electrons. Positive electrons. So now let us see. Electrons will travel from here to here, as a majority charge carriers are electrons in this case. So as it travels, electron travel here to here, so the direction of current will be, conventional current will this side. Why? Because more electrons are going in emitter plate, so that it can go outside. As it goes outside, what will happens is the poles will travel from here to here, holes, because of positive charge it will give a holes to here. More the number of electron, there is a recombination, so this is a current. Now talking about this, the holes travel from here to n side. Why holes travel? Why there is a hole travel seen? Because a hole is because this is a positive plate and holes will travel from here to here to decrease the interatomic repulsion between electrons present here and electrons coming from the emitter plate. So this will become the direction of IE. Why IE? Because current flowing throughout the ammeter. Conventional current, always remember, this is a conventional current and the direction of a current is a positive in holes direction, not in electrons. But the current we will refer to now is in day-to-day life is a direction of electrons, not holes. But in this case we are considering a conventional current, that is direction of holes. So this is IB, current in base, and this is IC, current in collector plate. So now by Kirchhoff's junction law. Kirchhoff's junction law. What does Kirchhoff's junction law suggest? It suggests that IE is equals to IB plus IC. This is what Kirchhoff's junction law suggests. So now let us see how can we represent in the NPN transistor. Let us see how we can list the transistor. So for drawing a transistor, this is the symbol of a transistor. Symbol. What is the symbol? This is a transistor. This has a base. This is considered to be a base, and this is a emitter plate. This is collector plate. Emitter plate. Here in NPN the currents go outside, conventional currents go outside, so the arrow is like this, and this is connected to another terminals. So it is IE, it is IC, and it is IB, which is current due to the base. Okay, this is emitter side, this is collector side, this is base. So this is the symbol of NPN transistors. Now moving on to PNP transistor. PNP transistor. PNP transistor. I'm going to discuss about the working of PNP transistor, and we have to know what its symbol is. So first of all, what we do is we draw the PNP transistor. PNP transistor. NP. So for a PNP transistor, we can see that this emitter is forward bias, this one. This is reversed bias, that is this type, and this is base, the base. So again here what we have in common of that of PNP is conventional current. Again we use conventional current. Convention current. What is it? Direction of or opposite to direction of negative charge, that is electrons. So now here we see what is that. This is emitter. So holes from here goes inside it. So increase the majority of charge area. As the holes go inside, we take the direction of convention current. So the direction of current will be going inside the ammeter, because here majority of charges holes. So what these holes are, these hole travels to a base, and here from negative terminal some electrons are going into inside. If electrons are going into inside, then where does the hole go? In this way. Why? We understand that because suppose these are electrons from this plate. This negative charge will travel in this direction. If the negative charge travel in this direction, the positive charge will travel in this downwards direction. So here, as soon as electron go, there are whole recombination of holes and electrons. Further, holes get travel to collector plate. In similar manner, as I suggest earlier, electrons from here get travel to here, from here to here. So now the direction of current will be in this way. Why? Because the holes travel in this way, opposite to the direction of electrons. So since the electron travel here, it prevent the interatomic repulsion between the holes which are coming from emitter plates and holes which are present in collector plate. So it will collect the current here. So now let us name the currents, that is IE, which is intercurrent. This is IB, which is base current, and this is IC. Here Kirchhoff's junction law what it suggests that IE is equals to IB plus IC. IE is equals to IB plus IC. This is a Kirchhoff junction law which also occurs in NPN conductor. So I think the flow of it increase. So here what we can see, the flow is entering into, in PNP junction the flow is entering into ammeter, and in NPN junction flow is going outside the ammeter. This is a basic difference between it. Now let us draw its symbol. Let us draw its symbol. Simple symbol. This is circle, this is base. Here this, in this way arrow is down. Why here arrow is down? Because arrow is down. Why? Because the current is entering through ammeter. This is collector terminal, this is ammeter terminal, and this is base terminal. So what is the direction of it? The base terminal current EI goes here, the ammeter current goes here, and the collector current goes here. This is the circuit symbol of Pnp transistor.